Hi to all. I am A.V. Laxman Rao, Assistant Professor in Physics Department of H&S. In today's session, I am going to explain you about what is effective mass of electron and how many different types of effective mass of electrons are there and how we can derive expression for effective mass of electron. Okay, so the three important concepts that I am going to explain. First, we will know what is effective mass of electron. Next, how many different types of effective mass of electrons are there, and at last we are going to derive an expression for effective mass of electron. Okay. Now, what is effective mass of electron? It is very important concept in quantum physics. Effective mass of electron is defined as here when you apply some electric field or any external field on an electron which is in a periodic field. Periodic field means what? If you take a metal, metal is a crystalline solid in which ions are arranged. All the red balls are nothing but red color, whatever the circles are there, they are nothing but the ions. And here the dot, thick dot, whatever is there, you assume that it is an electron. When you apply any external field such as electric field or the magnetic field or any other field, then by applying this external field, the entire mass of electron is going to be affected and it starts moving from one place to another place, one corner to another place. Mass of electron is affected by applying any external electric field or the magnetic field. Then the mass of electron is called effective mass of electron, we are calling. And in general, in quantum mechanics, effective mass of electron is represented by a symbol that is m. We are writing it is nothing but the general mass of electron as m, but we are writing there a star, m star followed by a star. M star represents here effective mass of electron. Okay, and this is the best example when we are considering the effective mass of electron. By taking an example, we can say. Now here, types of effective mass of electrons. How many different types of effective mass of electrons are there? We can say that effective mass of electrons are two different types. Two different types of effective mass of electrons are there. The first type is called infinite effective mass of electron and the second type is called negative effective mass of electron, we are calling. We have two different types of effective mass of electron. Let us discuss about what is infinite effective mass of electron and what is negative effective mass of electron. Definitions only we are going to see. First one, you take infinite effective mass of electron. To understand about these two different types of effective mass of electrons, I am taking the same example here. There is one electron which is located in a periodic field in a crystalline solid as like this. Now I am applying the electric field as an external field on this material in this direction. Then this electron is experiencing the force. Electron, we know that it is a particle, it will have some mass. So the mass of that electron, now it is having that particle is having. When you apply electric field, sometimes what will happen, you know, this negatively charged electron and positively charged ion, if at all having the very strong electrostatic attraction between them, even though when you apply the electric field, strong electric field also, you are unable to move the mass of electron. In such case, in such situation, the mass of electron is treated as infinite effective mass of electron, we are calling it as. What is happening here is strong electrostatic attraction is working between negatively charged electron to positively charged ion in that metal. Due to that, sometimes even though if you apply very high electric field also, you are unable to move. When you are unable to move, we are in general we are treating that the mass of electron is very high. even it tends to infinite also we can take. In that case, the mass of electron is called effective mass of electron. We are calling it as. Okay. Now, effective mass of that infinite effective mass of electron is over. Next type of effective mass of electron is here negative effective mass of electron is there. What is negative? Negative stands here. What is the meaning of negative here is direction. The momentum direction of the electron. In which direction electron is moving when you apply the electric field. We are applying the electric field in this direction. We are applying the electric field in this direction. But when you apply the electric field in that direction, electron is experiencing force in opposite direction. Due to that reason, the entire mass of electron here, entire mass of electron is moving in the opposite direction of applied electric field. Mass of electron, if at all, is moving in the opposite direction of the applied electric field, then in such situation, the mass of electron, effective mass of electron is called negative effective mass of electron. Mass of electron, entire mass of electron is moving in the opposite direction, negative direction of the applied electric field. Then the mass of electron, effective mass of electron is called as negative effective mass of electron. We are calling as like that. So, first type is infinite effective mass of electron and the second type is here negative effective mass of electron. Like that, we have two different types of effective mass of electrons. Now, let us see how we can derive expression for this effective mass of electron. M star, we know that is the symbol for effective mass of electron. Now, M star is equal to what? It depends on what parameters that now we are going to know by deriving an expression. Let us see. Effective mass of electron, if you want to derive an expression, we need to take a situation as like this. Here there is one electron which is negatively charged and this negatively charged electron is at one corner of periodic field and we are applying the electric field E on that electron. Then we know that due to the drifting of that electron here, that electron is going to be moved from one corner to the another corner. That electron is going to be moved. It is nothing but electron is acquiring some velocity due to applying of electric field. Now, when electron acquires some velocity, according to the quantum theory, the velocity that the electron was acquired in a one-dimensional potential lattice, one-dimensional periodic potential lattice as V, velocity equal to d omega by dk, we can write, where omega is angular frequency of de Broglie wave and here omega can be written as angular frequency na omega equal to 2 pi nu, we can write. Nu is frequency, angular frequency na, that's why we are writing as 2 pi nu we are writing. From this expression, nu can be written as, nu is nothing but, from this only I am writing, nu is equal to omega by 2 pi we can write. Okay. So, we are deriving final expression for M star. To derive that expression, we are taking some parameters as like this. First, I have taken the velocity. Next, in this omega is there na? What is omega? That I am writing as like this. So, omega is nothing but 2 pi nu and nu can be written as omega by 2 pi. Next parameter is there, that is k. K is nothing but wave number. We also know that wave number k can be written as 2 pi by lambda. In de Broglie equation, we have seen that k value, even in a particle in a potential box also, we have seen that k value can be written as 2 pi by lambda. So, we are writing k as 2 pi by lambda as like this. Okay. So, two parameters are over. By using these two parameters, now we are going to derive an expression for M star. So, first what we need to do, we need to take a well-known expression, Planck's law. Planck's electromagnetic radiation energy E is equal to h nu, we can write. E and nu, what is that relation? E directly proportional to nu. And also we can write E is equivalent to Planck's constant h into nu. But thing is here, nu is, equation 1 you take, in equation 1, nu is value is given. You see, here nu value we have taken as like this, omega by 2 pi. that value we are going to substitute here. New value is there, na? That value we are substituting here. Then we can write E as H as it is I am writing, H as it is I am writing, but new is substituted with omega by 2 pi. Take it as equation number 2. Take it as equation number 2. Okay. Next, equation number 2 you have written as like this. Now you differentiate that equation with respect to K. Differentiation of this E, energy, with respect to K. I am doing. It is nothing but d by dk of E. dE by dk. We can also say it as dE by dk. Energy with respect to K. I am differentiating. Then h by 2 pi as it is, whatever the value is there, h by 2 pi I am writing, and d omega by dk. Since omega is there here, that omega I am writing as d omega by dk. Why? Because both sides we are differentiating with k. That's why d by dk, d by dk. By taking as like this, we can write as like this. So dE by dk is equal to h by 2 pi into, here the value of v is exactly matching with d omega by dk. So we can write in place of d omega by dk, based on the equation number 1, we can write here as v. V we can write. Since v value here you see is d omega by dk. So overall we can write the velocity in terms of energy. The velocity in terms of energy as v is equivalent to 2 pi by h, whatever expression above is there, as it is I am writing, and dE by dk we got as an extra here. Okay. So from this we can write as like this. Okay. So you take that as equation number 3. Here I am writing v value. V value is nothing but what? 2 pi will go this side, h will come this side. Okay. And dE by dk as it is we are writing. That's why we got this expression. Equation 3 we got. Okay. Now 1, 2, 3. 3 equations we know. Now velocity final value we got as like this. Velocity expression we got. If you know the velocity, I want to know the acceleration of that moving particle. Then what we have to do? We need to do this thing. Here you see. V value you got as like this. Velocity of a moving electron in a periodic field. You got as like this. But the thing is, I want acceleration of that moving particle. Acceleration is nothing but what? The rate of change of velocity only. So what we need to do here to know the A value, dV by dt we need to do. It is nothing but V is velocity. With respect to time, if you differentiate that V value, then we are going to get A value. Okay. Now above equation, equation 3, if I differentiate with respect to t, I will get A value. So d by dt of V I am writing, which is equivalent to 2 pi by h as it is I am writing, where the d by dt is the differentiation with respect to t of dE by dk. Above whatever is there, I am writing as it is. Now by taking as like this, the acceleration of the moving particle can be written as, from above equation, 2 pi by h as it is I am writing. Here what I am doing here is dk whatever is there I am taking out, and dt I am taking inside. That's why we can write, by interchanging dk and dt, we can write here as d by dk of dE by dt. dE by dt, the meaning of dE by dt is what? The change of energy. When you apply electric field or any external field, the change of energy of that moving electron with respect to time. Change of energy. If I know this value, by substituting this value in this equation, we are going to get the final expression m star. Let us see how we are going to get dE by dt. Our task is now to know the dE by dt value. So dE by dt, according to quantum theory, when you apply electric field on an electron, electron is going to be experienced force, that we know. In opposite direction, electron will experience the force and it start moving. It is nothing but get accelerated. Then the energy absorption of that electron, due to that reason only it is moving now. So energy absorption is nothing but the rate of change of energy, can be written as how much force that it was experienced by applying electric field into whatever the amount of velocity that it was acquired. Force into velocity we are writing. So that is equivalent to the change of energy of that moving electron in periodic field. So force value we know, and velocity value also we know. Substituting these values in this expression, we are going to get dE by dt value. That value you need to substitute in equation number 4. So the next step what I am going to do is dE by dt is defined as like this. Now dE by dt is equivalent to force experienced by that electron in a periodic field by applying electric field, can be written as force is equal to charge of that electron into applied electric field. That's why we are writing E into capital E. Small e is nothing but the charge of electron, capital E is nothing but the applied electric field, and velocity V, as it is I am writing as like this. Okay. So here you see F equal to the force experienced by moving particle here by applying electric field, can be written as charge into applied electric field. Due to that reason we got this expression. Now next what I am doing here is dE by dt is equivalent to E into E, as it is I am writing. E into E, as it is I am writing. But the thing is V is there na. V is nothing but the velocity of that electron. For this there is one expression. Equation number 3 is there. That value you substitute here. That value you substitute here. I have substituted that value of V. Then we got here equation number 6 for the change of energy of the moving electron as like this. Now the entire dE by dt value, whatever you got, that you substitute in A value. A is what here you see. A is equation number 4, where dE by dt is there. Our task is achieved. Now A value can be written as 2 pi by h, whatever earlier is there, that is as it is I am writing. D by dk of here dE by dt value this is. I am substituting dE by dt value this one in this place. So dE by dt value by substituting here I got an expression as like this. Here you see A, as it is A acceleration, and 2 pi into 2 pi, 4 pi square. That's why we written as 4 pi square. H into H, that is nothing but H square we wrote. And here E into E, that is nothing but charge of electron into applied electric field, as it is I am writing. D by dk of dE by dk. Then second order differential equation of energy with respect to k, d square E by dk square. A value is nothing but the acceleration of that electron when we apply electric field on a electron in a periodic field. Acceleration we got. Now we move to the next step to conclude. M star can be written as how that we are going to see. Now you see acceleration of electron we got as this value, but we know that F equal to ma we can write, but the mass of electron here we are treating as effective mass of electron. F equal to ma, which is equivalent to charge into applied electric field. We can write both are F values only. M into A or M star A is equivalent to charge into applied electric field. For a charged particle, when you apply electric field, definitely it will experience force. That force F, which is nothing but mass into acceleration. That's why we have written this one. Now in place of here M star A, what we can write? Here M star into A. A is there. A value you got as this value. So substitute that A value here. Then this side and this side you have this side and this side you have A values. Why? Because A value you have substituted here as like this. Now based on this, if both A's are get cancelled, M can be written as it is nothing but here in this case it is a effective mass of electron H square by 4 pi square into d square E by dk square, as like that we can write. So overall we can write M star is equivalent to in terms of H by 2 pi, which is nothing but H cap reduced Planck's constant. In terms of that we can write the same equation as M star equal to H cut square by d square E by dk square. Our task is here to write the M star equation in terms of energy. So we have written as like this. In terms of Planck's constant H, and also in terms of reduced Planck's constant, that is H cap or H cut, we can write as like this. So this is the final expression for the M star in terms of energy and wave number. As like this we can write. So if you take the final expression in terms of Planck's constant H, in terms of reduced Planck's constant, these two equations we can write as like this. Either this equation you can write, or this also we can write. Both are here correct values only. Both are here the derived values only. Now here one more important thing is K, we know that the wave number, and E is nothing but the total energy of that electron, moving electron. Now if you take as E versus K is deciding the energy of that moving particle. If you plot a graph, you are going to get a parabolic shape of discontinuities. Parabolic shape of shapes you are going to get, and in between some discontinuities also you are going to see. This is nothing but E versus K graph we are calling. Here K is deciding the energy, K is deciding the allowed and the forbidden energy gaps of moving electron, as like this. Next one is, if you draw a graph between here the second one, dE by dk versus k, then we are going to get a periodic function graph as like this. If you draw a graph between the effective mass, this is the expression for effective mass, effective mass versus k. Why? Because here you see k term is there. So M star versus k, if you draw a graph, the variation of effective mass is going to be changed according to the k values as like this. Okay. So this is about the derivation of effective mass and E versus k, V versus k, and at last M star versus k graphs as like this we can say. Okay. And the final conclusion is, when electron is under the influence of applied electrical field or any external field, the mass of electron is called effective mass of electron. This mass of effective mass of electron is little bit different. It is quite different with the actual mass of electron. Mass of electron is different, and the effective mass of electron is different. Both are different. Depends on the situation. And overall we can say that two different types of effective mass of electrons can be expected, as negative effective mass of electron, and second one is infinite effective mass of electron. This is about what is effective mass of electron, and how many different types of effective mass of electrons are there, and final derivation for effective mass of electron, expression for effective mass of electron, how we can derive. Okay, like this we can say. Okay, thank you.